Hello, today we are going to be talking about 5.3 polynomial functions. So make sure you have your book out, and to follow along in the book, I'm going to refer to the book and the examples in there. So that might help just be able to follow what I'm doing here today. All right, polynomial in one variable. Okay, so in section 5.1 we talked about what a polynomial is, and we talked about the fact that the exponents have to be integers and the coefficients of the terms have to be real numbers. We also talked about 5.1 leading coefficient, but this is where they actually officially introduce it. And so leading coefficient is a coefficient of the largest degree term in the polynomial. So we'll talk about that here in a second. But first of all, let's talk about polynomials in one variable. If you have a constant polynomial, that's a degree of 0. An example of that would be something like y equals 5. That's a constant polynomial. It doesn't have a variable, or you can think of it as having x to the 0 power, which is the same as 1, so it's just 5. So that's why they call it constant, and that's why it's a 0 degree polynomial. Linear, we should know, is like mx plus b, y equals 2x plus 3. Something like that. That's a linear polynomial because it has a degree of 1. The leading coefficient would be 2 here. Quadratic. A quadratic polynomial we just spent chapter 4 on. The largest degree term is going to be a square, and so you might have 0.5x minus 3x squared minus 7. Well, negative 3 would be your leading coefficient. It's quadratic. This is not written in standard form. Cubic would have a degree of 3, so the largest degree term is 3. Quartic, 4. Quintic, 5. And then usually we just go right to nth degree polynomial. So like a 6th degree polynomial, you would say it that way. 7th degree polynomial, where the largest degree is 7. Okay, example 1a here. First of all, this is not a polynomial. And the reason it is not a polynomial, like we talked about in section 5.1, is you have an x in the denominator of a fraction. When you have a variable in the denominator, it is not a polynomial. Okay, so not a polynomial. 1b, 5x to the 6th minus 3x to the 4th plus 12x to the 3rd minus 14. Okay, so the degree here is 6. The leading coefficient is 5. So it is a 6th degree polynomial. So that's how you would say it. You would say a 6th degree polynomial. All right, here again, you're looking at 8x to the 4th minus 2x to the 3rd minus 6x, x to the 6th plus 3. Again, this is a 6th degree polynomial. The leading coefficient is -1. And then again, it's a 6th degree polynomial. So that's how you look at that. That's how you process what the degree is, what the name or type of it is, and look for the leading coefficient. We're going to be using that in the second goal today in 5.3 polynomial functions. Okay. Example 2, it's a type of a problem where it says it has the volume, and I believe that's time. Okay, so what's the volume after 4? So here's your polynomial function. This time it's written in function form. V of t, meaning whatever you put in here for t, goes in for t in the whole polynomial. So if we're looking for v of 4, you're going to put 4 in for t. So negative 0.0371 times 4 cubed plus 0.52 times 4 squared plus 0.173 times 4 would be my evaluating the volume at time t, or time 4. So again, you're just, whatever's in here in the parentheses, you're putting in for the variable into the function. Since 4 was here, we're evaluating at 4. We're going to put 4 in for t everywhere t is, and now we're just going to use the order of operations to evaluate it. And if we do that, we should get 0.7332 liters would be our volume. Okay, so I tried to express how to evaluate a polynomial function. We should know how to do that. This is called direct substitution because you're directly substituting in the 4 into the polynomial function. Now, the next set of problems are a little tricky. It's where you're actually substituting in variables and other polynomials into a polynomial function. So let's go to that. Okay, so example 3 here. 3a says that find g of 5a minus 2 plus you have 3 times g of 2a. Well, what the g means is just that it's the g function. Okay, so we have a g of a function, or g of x function right here. This is our g of x function. So what we're basically doing is we're finding g of 5a minus 2. So since g of x is equal to x squared minus 5x plus 8, since inside of the function is 5a minus 2, so g of 5a minus 2, we put 5a minus 2 in for each of the x's into the g of x function. So this is this, but it translates into this function. So we go ahead and evaluate that. If I square a binomial, we have to FOIL it. So 25a squared minus 10a minus 10a plus 4. Distribute this one, I get minus 25a plus 10 plus 8. Now I'm just going to go ahead and simplify this and get it into one thing. So 25a squared minus 10 minus 10 minus 25 is minus 45a just want to make sure I've got it, yep, plus 22, which is 4 plus 10 plus 8. Okay, so that's the first one. The second one, we need to multiply 3 times g of 2a. So the g just means it's the g of x function. And we're going to put in 2a into that function, but then in the end, we're going to multiply it all by 3. So let's go ahead and do that. So here I have the g of x function, which is x squared minus 5 times x plus 8. We're going to take that g of x function, we're going to multiply it by 3 in the end, because that's on the outside, but we're going to put 2a on the inside for x. And now we're going to evaluate it. So we end up with 3 times 4a squared minus 10a plus 8, which ends up to be 12a squared minus 30a plus 24 after I process that 3. Now, we just finished evaluating the second part. So now, in the end, we have to add these two. Okay, so we've evaluated the first part here, the second part here. Now I need to add them, so my answer ends up to be 25a squared plus 12a squared is 37a squared. Negative 45a minus 30 is negative 75a. And then 22 plus 24 is 46. So there is my final answer after I plug in 5a minus 2 for the first part, 2a for the second part, but then multiplied the whole thing times 3. Okay, you could take a minute here and try this problem. This is the second part, 3b. You can pause the video. I'm going to go over it here in a second, so you can check your answer when you're done. Okay, welcome back. So we are going to first process the h of negative 4d plus 3. So basically that is h of 4d plus 3 equals, now h of x is this, so that's 2 times x squared plus 5 times x plus 3. Since I am putting in negative 4d plus 3, I put in negative 4d plus 3 in for x, and I process it. Okay, so I process that, and that is going to be, first of all, I need to take 2 times, and then I have to FOIL that, which is 16d squared minus 4d times 3 twice, which is minus 24d plus 9, which ends up to be 32d squared minus 48d plus 18. Okay, so I'm ended up squaring it first and then multiplying it times 2. I'm going to go ahead and multiply this times 5, which is negative 20d plus 15, and then plus the 3 at the end. Now I'm just going to add like terms. I get 32d squared minus 68d plus 36. Okay, so that was the first part. The second part is negative 0.5 times h of d. So you're just plugging d in. So you got negative 0.5 times h of d. So what I'm going to do is I'm going to go ahead and write out negative 0.5 on the outside, and then I put my h function on the inside, which is 2 x squared plus 5x plus 3. But instead of x, I'm putting d in. So I put d in here. Now I process that. So I end up with negative 0.5 parentheses 2d squared plus 5d plus 3, which ends up to be negative 1d squared minus 2.5d minus 1.5. So I process the 0.5 through. Now I'm going to add like terms between these two because I'm supposed to add those. Remember, now this is adding a negative times that, so we're just going to add those up, and we end up with 31d squared negative 70.5d, 36 minus 1.5 is plus 34.5. And And there is my final answer, just like this was my final answer over here. So that is the section, or example 3A and 3B of the first goal of 5.3. Those are going to take a little practice, and those will be on the test, so make sure you give those some effort. I will make up a video for the second goal here, so that will help you with the second half of this section.